Okay, number 21, partial fractions. Typically a pretty lengthy problem to get from original fraction split apart into the sum of its two partial fractions. And look at, I tried to make this sort of like a multiple choice question, so our final answer is going to look something like A or B. First thing I want to point out, and this may help with process of elimination, those denominators are the factors. So these kind of individual denominators over here are the factors of that original denominator. So at least you might be able to eliminate an option or two if those factors are not correct. The other thing that we notice is the numerators do add to this term, but that's not quite good enough because we don't know what's going on with that -2. So we had this whole process. We split them apart. We threw some A's and B's in there, set up a system of equations, and tried to find them. But in a multiple choice test, let's just work backwards. If we take, let's say, option A here, and add those two fractions, and they give us our original expression, then that's the choice we want to make. So let's do that. Let's see if we can work backwards here. So I'm going to work through option A and see if this is right. Now, add those together. You do need to get a common denominator. So I am going to multiply the first fraction by the other denominator over itself, that x plus 1, and then the second fraction by x minus 2 over x minus 2. That's going to give me 4 times x plus 1 plus 3 times the quantity x minus 2 all over this common denominator of x plus 1 times x minus 2. And then I'll distribute. So I've got a 4x plus 4 plus 3x minus 6 over, I guess we could FOIL that, right? It's going to be x squared minus x minus 2. So my denominator is good. Maybe I would have tested that already earlier. And then let's just combine like terms here. I do have 7x minus 2 on the top, x squared minus x minus 2 on the bottom. That means, yes, option A was the correct one. Now look how similar A and B look, same numerators, but this stage would be different, so we would have some different terms that come out of that multiplication and combining like terms. But again, partial fractions, if you have the partial fractions in front of you as options, just work backwards and multiply.